Well, hello and welcome to Doc Onco's Physics. Keith Onco here. What we want to look at in this particular problem is the force that is basically due to static friction on a block that's sitting on a table or sitting on some surface. So what we can see here is the problem says that we have an 80 kilogram horizontal force. So we have a force here on this block that's equal to 80 kilograms. Okay. And it's applied to the 20 kilogram block, so this is 20 kilograms, which is at rest on a horizontal surface. And the static coefficient of friction is 0.6, so mu equals 0.6. What's the magnitude of the force of static friction on the block? Well, all we're really looking to find out here is what's the force due to friction. In this case, the force due to static friction. Well, so we have this equation, the force due to friction is equal to mu, which is the coefficient of friction, in this case the coefficient of static friction, times the normal force. Right? Do we really need to know anything about the fact that there's an 80 kilogram horizontal force on the block? It's really not going to make any difference, okay? Because the block is at rest, so the block isn't moving. So what we're going to be using this static coefficient of friction up here. If the block was moving, we would need the kinetic coefficient of friction, okay? So those are the two different types of coefficients of friction. Kinetic coefficient of friction if the block is moving, static coefficient of friction if the block is not moving. Okay, so the 80 kilogram horizontal force does really not come into play at all. So the force due to friction is going to be equal to mu times the normal force. So, well, what are the other forces on the block? Well, we have our force due to gravity, all right, which is equal to mg. And we have our normal force, all right, pushing from the table back up on the block. Well, if I want to know what the normal force is, I can write my equation for the forces in the y direction, right? And so I have my normal force, all right, going in the positive direction, so it's positive, minus my force due to gravity, which is mg, is equal to ma. Okay, well, is my block accelerating? Is it actually moving, physically accelerating in the y direction? Well, no, it isn't. The acceleration is 0. So in this case, Fn minus Fg is equal to 0, or Fn is equal to the force due to gravity. And the force due to gravity is just mg. Okay? So my force due to friction here is going to equal mu, which is 0.6, times Fn, which is equal to Fg, which is just going to be m times g, which is going to be 20 kilograms, times 9.8 meters per second squared. Okay? I'm not putting a negative sign in here because the normal force is a positive force. Right? If it was gravity, it would be negative. Okay? So when we do the math on this, 0.6 times 20 times 9.8, our static friction turns out to be, let's see, times 9.8 is 117.6 newtons. So that would be our static coefficient of, our static friction, right, on the block. And static friction is the friction before the block is actually going to move. I hope that helps, and have a great day.